And here we are in the lab again. And in this episode, which is episode 22, we are going to go one step above the last video where we generated audio waveforms. So we're going to do video waveforms in this one. We're going to generate a composite video signal, and we're going to put it on this TV over here. And so this TV I got for like 10 bucks at the thrift store like 5 or 6 years ago or something. And I've just been itching to make a project with it. So this is a great time to do it. And so first, we'll go over the general details of what a composite video signal is, and which I had to do in order to generate the waveform on the DAC. And it's actually not hard to do once you understand what it is you have to do. So we'll do that first, go over the composite video waveform, and it won't take long. And then we'll do, I'll show you the setup, what I have, and then we'll do a short demonstration to prove that it does work. And then we'll go over the code that it takes to write it, which the code is minimal. It's a fairly simple code. And then we'll do another demonstration of what the different parameters, how they affect the waveform itself to change the screen and stuff like that. So let's get to it. So let me give you a quick rundown of what we got. So here's main brain, of course, connected through the ribbon cable to our I/O board. All right. So now the I/O board, the DAC output is right here on, and I have this audio cable connected here. And we're going to use it for video, but it's an audio cable. So it comes over here like this. It comes down, it goes into a converter. So it's like when you had your video games, when you were a kid, you had to run it through the converter so it go through the antenna of the TV. Well, that's what we got. So then it comes out over here. The power, it runs on USB. We didn't do that in the old days, but yeah, it just plugs into the USB for power right here. And then the output here goes around to the back of the TV set right here. All right, to the antenna. And then we got a 12-volt power supply right here that powers the TV. So it's pretty simple. It's just like a basic game hookup, all right? So then what we're going to do is I'm going to demonstrate the speed of the DAC by generating a composite video. So let's take a look at some textbook stuff on the video waveform and kind of a little bit how it works. I'm not going to get into TV theory or anything like that. We're just going to breeze through so we know what kind of pulses we have to generate and kind of the timing. And then we'll just move on. Okay, so here's a video signal and from the textbooks. And you see the horizontal sync pulse right here. So that's one of the things we have to generate. All right. Now the color burst we don't have to worry about because we have a black and white TV. So this is just going to be a straight line here or more video. Okay. I had to go on mine. Maybe my timing's off a little bit, but I had to start right here at the edge of the rising edge of this pulse with my video information in order to get it to the right edge of the screen without a band in there. So then you have your video information, which is just an analog voltage for the brightness. The higher it gets, the brighter the picture. And so this, from this sync pulse to this sync pulse, represents one line across the TV. So for instance, this peak right here is going to be a certain brightness, more white than black probably because of its height. So if this moves across like this, then it's going to move across the screen. And we're going to see that. I'm going to show you how we can change this, change the variable in our Windows app, and we're going to move a rectangle across the screen like that. All right. So this is the basic interlaced video, 2 frames of 525 lines, and each frame has 2 fields, each with 262 and a half lines. So for if you just generate this first field right here, your TV will display its full screen. We'll get away with it anyway. So that's all we're going to do is just generate this first field. And then since that repeats, then that will complete your frame. So you're just going to generate 2 identical fields to make this frame. Okay. So if you do 262, it doesn't come out exactly even. So you're going to have a tiny bit of timing issue, but we're not going to worry about the details because we're not doing a TV theory video. We're just going to generate some pulses that mimic this and put a rectangle on the screen and call it good, because that just demonstrates that our DAC can do it. Then when our board's completed, we can write some fancy code and do some fancy stuff. But right now, we're just trying to get through the development process, all right? So we have to pay attention to this stuff here and generate these pulses here. And I'm not going to get into it, but you can look up the spec on how wide these pulses are. And these are the vertical sync pulses, and there's 2 per line until it gets to here. And then this section goes up through line 20. And this is where the video information starts. These are the sync pulses. And your video information is these humps right here. So the higher this, the brighter the screen, this line. In this example, this line would be fairly bright all the way across. All right. So that's pretty much what we have to generate. So let's take a look at a real live signal on the scope and compare it. Okay. So if we take a look at this video signal, we will notice that the sync pulses are pretty stable, and the data in between is changing to create the picture information. So the DAC has to be pretty fast. It not only has to create these sync pulses, but it has to be able to create the picture data too. Okay, so now let's look at the signal on the scope that our DAC on our board is generating and compare how it is similar and dissimilar. Okay, so here is what our DAC is putting out, and you can see the 2 bottom pulses, which is the horizontal sync, and the big pulse on top is the actual rectangle on the screen, one line of the rectangle. And so if you notice, it's in the middle between the 2 horizontal sync pulses. So that means it's going to be pretty much in the middle of the screen. Okay, so now let's take a look at, let's do a demonstration of it on the TV using our Windows app and see how it works in real life. Okay, so let's open up our Windows utility for MainBrain. Connect to MainBrain. Go to our utilities and generate waveform. All right, so I added the composite video checkbox in. So when you check it, then it changes the static text to horizontal and vertical and preloads some data into the edit boxes. So we're gonna take a rectangle on the screen and we're gonna move it around with these variables. So let's turn on our composite video. Let's get our board address in there and we'll send it over. All right, there you go. So you see we have a rectangle somewhat centered in the screen. All right, so when we change this variable, it's going to move it horizontally, right or left. And when we change this variable, we're going to move it up and down the screen. All right, so let's start with moving it a little bit to the left as you're looking at the TV screen. There you go. Okay. And then we can move it up and down with this one. So let's move it down a little bit, 200. So interlaced video, composite video, or yeah, the composite video signal has 525 scan lines. And so it's interlaced even and odd frames. So if you just repeat the same 262 lines over and over, it's forgiving enough and you can get away with it just fine. And so when you approach the 262, then it's going to be close to the bottom of the screen. So we'll send that over. And there you go. Down to the bottom it goes. All right. And then we can move it to the top of the screen by putting it close to 0. There you go. More or less to the top of the screen. Now, if you look, the camera gets a horizontal line going across it, like as if your vertical hold is off or something. That's just the camera interacting with the frames of the video. So, but you can see down here, we have a little bit of a timing issue. And you can see that there's like a little streak and some shadowing here. That's our signal. We can clean all that up, but we're not going to do that here. This is just only for test. And then later, when we have a finished board, we'll write some really cool composite video code. But for right now, that's what we got. And we proved that the DAC can generate composite video. We proved that our circuit works, and we're ready to move on. Now it's time to look at the code and see the relationship from the code to the actual rectangle on the screen. And here we are in the code. So all the handling, all the action takes place in our interrupt handler file. And so when we come down here and we get a command and we read address, SRAM address 0 to get the command, then we do a switch statement. And when the switch statement is 4, then well, the M data, which creates the case of the switch statement, when it's 4, then it comes down here and it reads address 4 for the subcommand, because case 4 is the DAC waveforms. And then we have the checkboxes. So when you check a checkbox, this is how it determines which checkbox. So when M data is 8 for at memory location 4, then we jump into this routine. And so then we get the horizontal value from address 2 and the vertical value from address 5. All right. And we load it into these global variables here so that we can use them in the timer interrupt. And so we set the no prescaler in the clock division. We turn the DAC on, and we set the period of the timer to this value, which is the frequency of the the horizontal sync pulse, okay? And then we turn the timer on, set the wave mode to 33, make sure the triangle wave mode is off on the DAC. So then we break it out, and then the timer takes over from there. So we come down here to our timer interrupt. So we started the timer, so it's going to start doing an interrupt, right? So we set the wave mode to 23, which is composite video. And so then this is our pulse generation here. This is our pre-equalizing, our vertical sync, our post-equalizing, and the color field, which is just like a blank spot for right now. So this is for the first 3 lines, as we've seen in our textbook. And then we go 3 more, and then 3 more. And then these continue on, which is basically a horizontal sync without any color, without any white. It's just black for up and through 20 lines. So every time that the timer interrupts, that's 1 line of video on the screen. So this is the picture information above line 20. All right, so it comes all the way down here until it hits line 260. I have 280, but it can be 262 or more. I was messing around with that. Okay, and so here are our global variables here, the horizontal. So for the vertical, we select the line. All right, so this if statement right here creates the height of the rectangle, which is 10 lines. So 50 plus whatever the vertical is. So if it's 0, then it's 50. If it's 50, then it's 100. And that's always, the height is always 10 in this case. So from the Windows app, we can change these global variables and move the rectangle up and down with this. Now, the horizontal global variable is the timing across the 1 line, okay? So this is a delay, just a for loop, so it loops this many times, and that delays it from the end of the rising edge of the pulse, the end of the horizontal pulse. From there, it delays it out to the right of the screen. So the higher this number, the farther it moves, the rectangle moves across the screen to the right. All right. And this variable here, the level, is the kind of what you would call the background level. You could make it lighter or darker, and you could switch it to where this is a higher level, and that you can cause this to be a lower level by changing this. So if this variable, or right here, this value was lower than this, then this would be darker than this one. But right now we have a white, fairly white rectangle, and the background is fairly dark. All right. So that's how it changes. It's just a few lines of code can make a big difference, do a lot of work. All right. Okay, so now what we want to do is we've seen how with using the Windows app we can move the rectangle across the screen, but let's look at the waveform when we do that so that we can see a relationship and understand it a little bit better. Okay, so testing 1, 2, 3. All right. Okay, here we are in the code, and I did a real quick change right here. I added the equal sign here so that it gives us 10 lines for the height, and I just no particular reason. I just wanted 10 to make it even. I just thought I'd mention that in case you look at it and it's like, wow, there's an equal sign there. All right. So let's start up our generator. And so you see our pulses here. And there's one line right there. And you can see that our rectangle, our video information, is in the center between the two synchronization pulses, which means that it is in the center of the screen. So if we go over here and we just move it over to 10, whoop, like that. So you can see it move to the left, and that means the rectangle moved to the left of the screen. Okay, so now the width of that pulse is right here, which is 80, and that's the width of our rectangle. So if you change this variable here, this value, then it changes the size of the rectangle, the length of it. This up here, the lines change the height of the rectangle. We can't demonstrate the vertical on the scope because it's such a 500 or 262 lines is so long on the scope, and you can't trigger. You'd have to be able to trigger on something that was separated from the vertical sync so that you could see it change, but we can't do that in this, at least right now. I'll look into it and see what we can do to show that later when we do our big demonstration on our finished product. But so we can go, I'm only grabbing 8 bits for right now for the test, so we can only go to 255 on this horizontal variable. And you see it moves quite a ways to the right. Doesn't get all the way to the end, but it's getting there. And so then we go back to the 180, and that puts it back to the center. So that's pretty much how it works. The height of the video pulse is, of course, how white it is. So that's why the background information that surrounds that pulse is low, which is black. So you could raise those. You can raise the level here, the background level, and make it less dark. or you can flip them and make this a high like an 800 and make this a 300, and it'll flip it to where you have a black rectangle and a white background, or anywhere in between. So I could add a couple more boxes in here and send the data across, because I have it set right now where when you send information, it sends the whole 64 bits through the USB into the SRAM every time. So we can do lots of boxes. So you could actually change this level, make it global, and put a variable here for this and make it global. And you could change the height, the width, the position, the whiteness. You can darken it up. You can make it gray. You can do a lot of different things. So that's beyond the scope of this video. So yeah, that's pretty much it. That's the whole concept, and just a few lines of code can do a lot of work on the screen. Okay, there you have it. We have generated composite video, and this board is coming along really well, I think. It may seem kind of boring sometimes, or it's taking a long time, but that's the way it is when you develop a board yourself and you don't have 8 hours a day, 7 days a week to work on it, and a bunch of engineers and programmers and stuff. It takes a while, and it's a lot of work, and you have to wear many hats. I still got lots of documentation to do on everything. I don't know when I'm going to do all that stuff. I have to update the website. I have to make some promotional stuff, and it's going to be a busy year, and I'm busy in other things too, because summer's coming up, and I got projects in the machine shop. I got Jeep projects. I got house projects. I got work projects. We got lots of stuff to do, and then but it moves on. You move forward, and it takes time. And if it's not moving fast enough for somebody, there's not much I can do about it. So I think it's a good time right now just to take a quick chat about the future of the project. So this specifically the I/O board. We got a few videos left. Coming up next is the analog to digital converter. So with that, we're going to be able to like do the reverse of what we just done in the last two videos, meaning that we can like record, we can measure audio signals and record it and stuff it into memory. And it's the same thing. We should be able to do that with composite video too. And we should be able to strip the sync pulses and the vertical pulses off. And just get the video data and store that into memory and then play it back. And hopefully we can transfer it through the SRAM into mainbrain, and hopefully like in real time kind of, and display it on the screen. So we can do like a little digital multimeter, and we can do maybe some kind of little scope thing. I don't know how we can do a fast scope type of thing, but we'll experiment with it. And we still have a video we're going to do on modulating the PWM. So you can have a PWM output, square wave and stuff, but you can modulate it for the pulse width modulation. And so we got a video coming on that probably. And then we're going to have to do some, I'm looking like we're going to have to do an analog multiplexer switch type chip on there. And then we're going to get our MOSFETs to switch external voltages and stuff. We got to get that on there. And then once I'm working on the schematic and the PCB. I haven't really done much on the PCB yet because I want to get the schematic done now and then do the layout of the PCB. I want to change a lot of the layout on that. I want it a little bit better. And so that's pretty much it. then I'll order the PCBs, and I don't know how if I'm going to be able to order from PCB Waste since it's in China and we got some tariff things going on, or if I'll even be able to afford to. I don't know what's going to happen on that. But even if I have to go locally, pay a little extra, I'm going to get a new PCB shortly. Maybe within a month, we'll have a new PCB with the new flash on there, so we can test it and store information in there and play it back and stuff. And so that's that'll be towards the end of the project by then. And then we'll do some like performance testing and make some little bit of more fancy code stuff, and we'll go from there. And things will develop in between there, and we might change our mind on some stuff. And like we did on the composite video, I hadn't thought that we could do that with this microcontroller. So um, we're doing good. I'm proud of the project, and I'm happy with the way it's going. So I will see you in the next video.